Okay, picking up where I left off. All right, writing in characteristics of the polynomial here. What you have here is we've got 1, 2, 3, 4, 5, and 6. So that's at -6. That's a 0. 1, 2, 3, 4, 5. That's 5, and that's a double root. Okay. So when I make that polynomial in factored form, x plus 6, x minus 5 squared, because that's a double root. Now, what you have to watch out for, it's not the case in this, but since this is like that, that's positive. If that would have gone that way, I would have had to put a negative out front, so be careful of that. Okay? Here it says sketch a polynomial as real 0 at -3 and at 5 with a multiplicity of 2. So here's what that means. Let's put the real zeros in first. Multiplicity of 2. 1, 2, 3, 4, and 5. So since it's got a multiplicity of 2, that means it's got a curve. Okay? So what I should do here is this should go like this. Okay? Because it's got a touch and go because it's double root. Now, I got 3 real, okay, because this counts as 1, this counts as 2, total of 3. They want me to put 2 zeros that are imaginary. So that's 2 imaginary. So here's what that means. I've got 5 zeros. That means I have a degree 5, okay? And if I have a degree 5, I've got to have 4 turn points. Now, as you can see here, I got 1 and 2. So what I got to do is I got to make 2 more, 1 and 2 more without touching down there because I don't have any more real zeros to use. So as you can see, I got 1, 2, 3, 4 turn points. That makes that logic work. Okay. This is a cubic. Now keep in mind our normal cubic function is 1, 1, 2, 8, -1, -1, -2, -8. Okay. Now. My anchor point just is normally 0, 0, so my anchor point here is right there. So it's 1, 2, 3, down 1. So it's -3, -1. Opposite on the inside, follow on the out. I know it's a cubic, okay? Now, normally I go right 1, up 1, but now I go down 1. So if I go down 1, and if I go right 2 and then down 8, the only way that becomes is I would have to multiply by -1. So that gives me that, okay? Moving on. Once again, same old cubic numbers, 1, 1, 2, 8, -1, -1, -2, -8. I'm starting at -3, 1, 2, 3, 0. All right, and so I'm going right 1, up 1, right 2, up 1, 2, 3, 4, 5, 6, 7, and 8. Left 1, down 1, left 2, down 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so here's my graph. Okay, now this is a quartic. My quartic graph, let me make sure I can see that over there. Okay, yep, I got plenty of room. All right, so my normal quartic graph is 1, 1, 2, 16. Okay, -1, 1, -2, 16. It's very much like a quadratic, but obviously you're doing it to the 4th. Now, my anchor point here is 0, 2. Okay, 0, 2. So I'm going 0 over 2 up. Okay, now since I got that -1/4, I'm multiplying these by -1/4. Okay, and I know it's hard to see that, but basically that's going to be -1/4. 16 times -4 is -4. Okay, so I'm going right 1, down 1/4, right 2, 1, 2, down 4, 1, 2, 3, and 4. Left 1, down 1/4, left 2, down. So it looks very much like a quadratic. It's just going to be stretched a little longer. Okay. Moving on to 18, division of polynomials. The way that works, okay, 2x and -1. This first term goes in here. So what that tells me is I'm going to have an x squared. I'm going to have an x term. Okay, I might have a remainder depending. This times this has got to give me that. The only possibility there is x squared. The logic now tells me it's this times this gives me this, which is -1x squared. Now, these diagonals have to get to, if it's x squared, it's got to get to this number here. So the only way to get there is to get to -6. -1 minus 6 is -7. Okay? Now, this times this has to give me that. The only thing that would work there is -3x, which tells me that this has to be 3x. Now, my diagonals here have to get to 11, so this has to be 8. The only way that works is that's 4. If I multiply that, it's -4. Now, my number here is 5. So this is where I'm going to have the remainder. I got to get to 5. Well, how would you get to 5? You would add 9 to get to 5. So my answer here to this problem, I've used this already, so this can't be part of my answer. It's going to be this, 3x plus 4, plus 9 over 2x, shouldn't erase it, cross that out, 2x minus 1. Okay? And there's my answer there. It says completely factor. Okay? All right, state and then find all the zeros. So what I'm going to do is I'm going to go to equal here. All right, I'm going to go to menu and equal. I'm going to see if I can find any of the zeros. So my polynomial at degree 3, all right, I'm going to type in 1. The x squared term is negative 1. Oh, whoops. Is negative 1. My x term is negative 5. And my term over here is negative 3. And I'm going to solve. Okay? Now, what that means for me is I got x equals 3 and x equals negative 1 is repeated twice. Now, since it's degree 3, max number of real zeros, so I'm finished. The factors of this are pretty simple. X minus 3, x plus 1, x plus 1. You could have also written it as x minus 3, x plus 1 squared, because it's a double root. Okay? Moving on. Okay? Is this a factor? Okay? A couple of ways you can know that. If this is a factor, then 2 would have to be a solution. Okay? And if 2 is not a solution, that doesn't work. So I'm going to type in 2, 8, negative 3, negative 1, solve, and 2 is not a solution. Okay? The other way you could do it is divide this and see if there's a remainder. So that answer is no. You can either 2 is not a solution. Another type of answer would be no, or, all right, no, because there's a remainder. Because of remainder. Okay? All right. Given this, divide that, okay? We're going to go ahead and do that. So once again, I'm going to start 3x cubed is going to go in here. 3x plus 1. Since it's x cubed, I know I'm going to have x squared. I also know that I'm going to have x, all right? The only way this works is if this is x squared. This time this has to give me that. That's 1x squared, okay? I got to get to 7, so I got to put up 6. Whoops, I don't need that little line there. Okay? Okay? The only way that works is if that's 2x. Okay? All right? That would give me 2x. I got to get my x's to be negative 13, so that's negative 15 is the only way that would get to negative 13. The only way that logically works is that's negative 5. Okay? All right? And this would be my answer would be negative 5 there. Okay? Negative 13. I'm going to double check that that's right. All right? And then that's going to be the remainder there. Let's see, this is not the one where you have to find all the roots, is it? Okay. All right, let me double check that I'm doing this right. You shouldn't end with a positive, a negative answer there. Okay, so, all right, so what I need to do is I'd have to go to plus 10. Okay, all right. Actually, hold on, I'm going to pause this video for 1 second, make sure this is the right problem.